Hi everyone, I am back, and if you have been following my previous video, then you know that today we are going to do some stuff with GTFS data. If you haven't been here last time, just check the previous video and also be ready because we are going to dive into GTFS data and visualize public transport line information. So let's just dive into it. After minimizing myself as usual, we can just start by copy-pasting the root folder while I still keep my geospatial or my GTFS data. We can still have a sneak peek into this folder to see what we have here. As you can see, in this GTFS folder we have stop times, shapes that contain information about the exact routes, exact shapes on a map, where each bus and tram and subway goes, and a few other information, for example stop locations, which we have seen in the previous video. So first let me just parse the shape file very quickly. So pandas, import pandas as PD. I will call the DF data frame our major star today. So DF should be the PD read CSV of the shapes.txt file. We will have a data frame of about 500,000 records, and these records, as you will see, are point geometries. These are actually the points of the different lines or roads or GPS traces every single vehicle moves around or across. So that's why we have so many data points here. And once we have this information, we can start to turn it into a geodata frame. It's a very similar process than what we did to the stop locations. So from Shapely, I will first import points, but also line strings, because while for stop locations we only needed points, so there the natural geospatial format was points. Here we will use line strings as well, because at the end we want to draw the lines of the routes on a map. So I will just create the geometry column of the data frame first, which is going to be based on this list of tuples. And if I'm right, then it's shapes.pt._let probably. And maybe that's enough to get the geometries. Okay, there is a typo here. Let me just, it's not shapes, but it's just shape, right? And not underscore, but point, okay. It takes a little longer because that's a gigantic data frame. So now we can have a look. Now we have the geometry field, but we also need to turn it into a geodata frame. So gtpd.geodata frame df. We will need a few new fresh cells. And we also need to import GeoPandas. And let me just plot a smaller sample of this geodata frame so that we have a look on how this point data file looks like. It's indeed points that kind of look like they are scattered around Budapest, so that kind of makes sense or checks out. But it's still points and not like lines covering the routes. So let me show you how we can actually group by the shape IDs. So let's take a look at the data frame. See, one shape ID, that's one line or one line string or one route, has multiple points. So for example, if you want to filter for this VF shape ID value, then we can see that there are more than 100 points that belong to this particular route. And now it's not a geodata frame, so I just turn it into a geodata frame very quickly and plot it. And now you can see that this was actually one route. So we somehow want to connect these dots and replace these 100+ points by just one string, line string. So we can do that by first grouping this data frame by the shape ID, and then joining all the points within one group to be a line string. So group by by shape ID. We also need to aggregate into a list. And I will call this GTF2 for now. Okay, this might take a while, but don't worry, it will be done, well, rather sooner than later. And once we have it, yeah, see, so here we don't really need any other column but the geometry. At this point, as you can see, geometry is now a list of points, and now we need to convert that list of points into line strings. So GTF2 will have a geometric column as well, which will be derived from the current geometric column by applying a lambda function line string on the current lists of points within the data frame. So if we do that, we should have a geometric column that only has line strings. And that's it, here we have it. So if we plot it now, then we will have line strings. Or we will almost have it. So let's see the type. Maybe this is again a pandas data frame. Yep. So let's turn it into a geo data frame again. And once we have that, we can plot it very easily like a nice geodata frame. So we are almost there. It's very similar to what we had before. So now I will create what we had before in the case of stop location. So now I create a nice canvas and I call it F and AX as usual. I call for the subplots, set the image size, let's see, we have a shape ID column here. Ah yeah, GTF2. I will also add the shape ID 2, which is actually going to be the index column. So we will just copy the shape IDs to this new column as well, so we can use it for coloring. And now I will say that GTF2 is plotted on this axis. The column we plot is shape ID 2. So now every line should have a different color using the color map. Tab 20, a line width of, let's say, 1. And almost there, it still has some issues. Maybe it's still not a GeoPandas data frame. Yes, so let's convert it here once and for all, GTF2. And here we are. So this is all the public transport maps or public transport lines in Budapest, each colored differently. So actually that was it for today. So once again, to wrap it up, we parsed the shapefile that contained all the locations of every line string that belongs to the public transport routes. First, we turned it into a geodata frame of points. Then we merged these points based on the shape IDs, and we arrived to a long list of line strings, where each line string corresponds to one particular route that one vehicle, either a tram or a bus or a subway, moves along. And finally, we put it on a map using Matplotlib. So I hope that you had fun watching this video, and let me know how you managed to reproduce the code. Bye.